let's see what this thing is called arrays. Up to this point, guys, you were dealing with variables, bunch of data types. And now tonight you're going to learn how to use a collection of these variables. So up to this point, if you needed to submit or to pass rather to a function, bunch of quizzes, you had to use multiple variables. So if you had 3-4 quizzes, you used 3-4 arguments, and that was okay. But let's say you needed to collect 20 quizzes. That would mean 20 variables, 20 parameters, 20 arguments. So it just becomes not practical. Furthermore, when you deal with when you allocate your own variables for each quiz, let's say you have to keep track of, I don't know, 10, 15 quizzes, then the way that's done, the compiler allocates these variables as it finds location in memory. So let's say this is quiz 1 and let's say this is quiz 2. They may be next to each other for all we know, but we don't know that. Then quiz 3 may be somewhere here. Quiz 4 may be here. Quiz 5 may be here. Quiz 6 may be somewhere here, and so on and so forth. Right? So you have no way of traversing these variables other than referring to them via their identifier, via their name. So when you deal with arrays, you allocate a block of memory contiguous like this. And inside of that block, you have elements, and each element is the same size. They are all of same data type. I know some of you took Python before, and you come from that world where you could have a list, and list can hold different data types. That's not the case in C++. In C++, all of the members of this collection, of this array, are of same data type, whatever that type is. All right, so they're all same data type. So let's say this was an integer array, then this would be 4 bytes here. Then another 4 bytes here. And another 4 bytes, and so on and so forth. Okay. So how do you access this? So let's say I allocated this and I call it quizzes. So this is my array and this is quizzes. And quizzes contains quiz scores for, let's say, a student. So student scored 100 on the first quiz, and let's say 98. Then on the third quiz, maybe they scored 87, then kind of dropped the ball, scored 71. And the student studied, and let's say they scored 91. So 5 quizzes. I only had 5 quizzes for the student. The rest, I don't care, right? But if I want to access these quiz scores and compute the average, I need to access them through their location. So quizzes refers to the entire thing. So quizzes is basically this whole thing, this whole block of memory. But then quizzes in position 0 is the first quiz score. Second quiz score is in position 1. This one is in position 2. This one is in position 3, 4, and so on and so forth. Okay. If I had more quizzes, this would be, let's say, position N. N meaning I don't know how many I have, so maybe I have 300 quizzes. Okay. So let's say this was the last quiz score and they scored 90 on it. All right. So this index, this is called index. These positions, or it's also called subscript or index. And that's the only way for you to access it. So rather than having multiple variables, quiz 1, quiz 2, quiz 3, quiz 4, quiz 55, quiz, 200. No, you have only one variable. Now, if you want to access this guy, then you have to access it through this operator. It's a square bracket, and then you provide the position. And you provide, in this case, if you want to access 100 and display it, it's in position 0. 98 is quizzes, and we say sub 1. 87 is quizzes sub 2, and so on and so forth. Sub is a shorthand for subscript. Okay? Now, why is starting at 0? Why not at 1 and 2 and 3 and so on and so forth? It's very simple. When you're here at the beginning, this first position, you haven't offset into that block of memory at all. So you put your value in here, and then if you want to get to this position here, where 98 is, you need to offset 4 bytes into it. Okay, so you offset, you're here, you need to offset 4 bytes into it to get to it. Why? Because here's 4 bytes. So how much did you offset? 1 times 4. If you want to get to 87, how much do you have to offset? You are at the beginning, so you're going to go 4 bytes. That's 1. Remember, another 4 bytes. So this is position 2. And you offset 1, 2, right? And each member, how many members did you offset? That tells you the position. How far did you go into that block of memory? Does that make sense, guys? Yeah? All right, so keep that in mind. Now, this is in case of integers. If we had doubles instead of 4, you would be offsetting 8 bytes. And also keep in mind on architecture that we use, which is Windows and Intel, Mac OS runs on the same architecture. It is 4 bytes for integers, 8 bytes for doubles, 2 bytes for shorts, 1 byte for character, and so on and so forth. If you were to work on a supercomputer, then that may be a little bit different. Maybe integers on supercomputer are 8 bytes and doubles are 16, depending on the architecture. But for, unless you get a job in one of these Lawrence Livermore lab or NASA or, one of these like government places where they have supercomputers, you are most likely going to work on Wintel architecture, Windows/Intel, where integer is 4 bytes, and so on and so forth. Okay. All right. So that's a little bit of background what arrays are, and they're pretty easy. This is your first data structure. They're a little bit cumbersome, a little bit wasteful. We're going to see where that comes and why is that. But it saves you from sending, let's say you're collecting 200 quizzes. That would be one very, very long function call where you would have 200 arguments to send 200 quizzes into your function versus sending only one variable called quizzes, and it may contain 200 elements in it, and one variable, one parameter, one argument. Much, much easier. Natalie, go ahead. You raised your hand. What is your question?
I was just wondering, did you say anything else before? Because I just got here.
I did say quite a few things, so I'm recording this, and you can review the video after the class. So yeah.
Oh, okay.
Yeah. All right. Okay. So let's go ahead and see what Tony Gaddis has to say about this, your book author. So as you know from my little introduction, array can hold multiple values, and it's nothing more than a variable that can store multiple values of the same type, and they are stored in a contiguous block of memory. So they're all in one block of memory, and that's why you can use subscript or index to go through that block of memory and access all these variables. Now, to declare it, you use this operator. And you've learned when you declare variables to do something like this. You have data type, like so, and you have identifier. And then you have semicolon. So data type, let's say double, and then identifier is miles per gallon. Name of your variable, miles per gallon, to keep track of miles that your vehicle or motorcycle is using. We could have also more complex data type like string, And then here we can say first name. But the principle is the same. You see, the pattern is the same. I have data type followed by identifier. Now, with arrays, what you have is data type. Okay, so in this case, what you see on the screen is integer, and the identifier is tests. And then this here is the dimension. This number 5 here is how many integers do you want in that contiguous block of memory. So with this declaration, the compiler is going to allocate 5 integers for you to use, okay? And you're going to refer to them through common name called tests. So here's the first one, here's the second one, here's the third one, here's the fourth one, okay? And you now know that the first subscript is 0, this one is 1, this one is 2, this one is 3, and then this one is 4. So we're going to talk about this. It can be confusing for novice programmers when they look, they say, how come it says 4, but I have 5? Well, you have 4 because it starts from 0. But if you count, you still have 5. And we'll talk about it as it's called off by 1 error. But just understand that the same pattern is used. You have data type followed by an identifier. Identifier is a variable name. So same rules that you learned about what constitutes a good identifier apply here. Can start with a number, must start with a letter or an underscore. And then you can have uppercase, lowercase letters in it. You can have numbers in it, numeric, and so on and so forth. But all those rules apply. So the only new thing that you're learning is this operator and then the dimension. Dimension is that's this number here, which we call dimension or size of the array. So keep that in mind. I'm going to put here that this is dimension or size or number of integers or doubles or characters or whatever else you are allocating. All right, so moving forward, let's take a look at the next slide. So here, this is pretty much what we saw. So you allocated 5, basically 5 times 4, 20 bytes. And first element is in position 0, second in third, and so on and so forth. Now, you can easily compute memory requirements for your array. The way you compute that is you take the dimension and you multiply it by the size of your data type. Okay, so let me give you a couple of examples. Oops, I don't want that. I want this. So a couple of examples of that, and let's see if we can figure it out. I have something like this. I have car, and let's say alphabet, and how much memory did I allocate? Anybody? How much memory did I allocate with that? How big is a character? How big is a car? How many bytes? What am I showing you?
1.
1. Okay, so what is the size of your array? What did you request? You requested 26 of them, so you're going to have 26 bytes. Okay, let's try something else. Short, and let's say quiz scores. That's the name of my array. And let's say I have 10. How many bytes am I going to allocate here? Short is 2 bytes. How many bytes is my array going to occupy?
20.
20. Very good. So 20 bytes. So you see how that works. And then let's try something else here. I have double. And let's say this is, I don't know, let's say payments. And this one is 12. How many am I going to have? How many bytes am I going to have? How big is double? If integer is 4, what is double?
8.
8. Okay, so how big of a memory allocation I need here? What's going to happen? I'm going to have 12 times 8. 10 times 8 is 80 plus 16, 96 bytes. Everybody see that? 96
Yes.
bytes. So you take this, which is size or dimension, and you multiply it by whatever memory requirements are for that particular data type, right? And that's what he is telling you here. Okay, so this tells you how many elements you're going to have since they're all of the same data type. So these are all shorts, these are all cars, these are all doubles. You basically take this and you multiply that by the data requirements or data size of your data type. So if it's double, it's 8. In this case, I have 12. 12 times 8, 96. All right, moving forward. Let's take a look at so that's basically what we did. Now here he's showing you long double. It's going to give you 80 bytes because 8 bytes is for a long double. Integer is 5. Each integer is 4 bytes on our platform, on the platform that we work on. So that's going to take 20 bytes. So understand that this is for most platforms what you're seeing here, but it can change in case you end up working on a different hardware, such as supercomputer. Then you have to figure out how big is each data type on that particular platform. All right, now there's some couple of hints, some good programming practices for you. You have learned in the past that you can use what you may call it functions, and you also learned about global and local variables. And you know that global variables are not a good programming practice. Can somebody elaborate why? Why do we say that they're not a good programming practice? What's the problem with global variables? Does anybody remember from your functions? What is the problem?
They usually work outside of the function.
Okay, so that means they're in scope throughout the program, and any function has access to your global variables. Thereby, any function can change it. And if you have a lot of functions in your program, you're not going to know which function changed it. Especially if multiple people work on the program, on the project, then that could be a problem. So that's why you don't want to use global variables. You want to use local variables as much as you can. Actually use local variables all the time. Global variables are not good, so you're not going to use them. I correcting myself. And we here are talking about named constants. Can I use named constant as a global constant? Is that a good practice?
Yeah.
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 Yeah. Okay. Why? You're correct. Why?
Because value cannot be changed.
Yeah, constant cannot be changed. So saves me from passing that constant into my function. So if it's visible, if it's in scope throughout the entire program, then any function that needs to, for example, allocate an array of this particular size, I don't need to pass that size to the function because I declared a global constant and no function can change it. So the code is safe. Okay. And also, when you declare it like so, whether it's global or local, it's very easy. Let's say your initial data set, when you're writing your code, it's only 5 elements, but the real set is maybe 5,000 elements. So rather than changing it, like you're looping through your array and you need to know the size. So wherever you have a loop, you're putting 5,000 there or 5, and then you need to replace it with 5,000. Then you got to hunt through your code and look for wherever you have 5, you want to replace it by 5,000 or 999, whatever the real size is, right? But when you do it like so with a global constant, you make one change and you use this global constant identifier in your loop, in your array, in everything that you can think of. Okay, so this is very good programming practice. So, make it a habit of yours. You're building now, you're learning these things, and now you know what's a good programming practice, what's a bad one. So all these good ones you should use because it's going to make your code easier to debug, easier to write, more readable, all the good stuff that we preach in this class. Okay, so let me demonstrate. So we're 5189, right? So we're going to declare an array. We've been discussing a lot of theory, a lot of what an array is and all that, but let's look at, let's say, source code 01, and this is going to be intro to arrays. Arrays, and I think I need to put an underscore here. Let's see how we can declare an array. So let me just clean this up. Oops. Okay. It does help all this, but okay. All right, let's do integer main, and then let's return 0, and then I'm going to declare a global constant. So constant integer, let's say array size, and let's make it 5. So I have an array size like that, and we're not going to write functions yet. We're first going to learn about arrays, and then hopefully, if not tonight, then in the future lecture, definitely you're going to see how to pass arrays to functions. So I'm going to declare an array called my array, like so. And this array is of ARR size. All right. And I want to populate that array. So as you see, this AI tool is offering me to do it in a loop. I'm first going to show you without the loop. Then we're going to do it in a loop. So I want to, what you have here is basically one variable and 5 integers in it. Okay. And we're going to populate that. So I'm going to say my array sub-0. Sub-0 means subscript 0 or index 0, and I'm going to give it value of 10. Then let's say second one is 20, third one is 30, 40, and 50. And that's what you do. Okay. So I have 5 elements. See how my subscript or index goes from 0, 1, 2, 3, and 4. Okay. Now I want to display this array. So I'm going to say 4. I'm going to use a loop, and I'm going to accept what this tool is offering. So I is index. We start at index 0, and as long as this is not equal to array size, I want to loop through it, and I want to display it. So let's display it, std, cout, and here I'm just going to say, I'm going to leave it like this. Okay, let me share this with you before it gets too big, so you can try on your end. And let's compile and run. Let's see what we get. So you get 10, 20, 30, 40, 50. And there it is. It displays it quite nicely. Okay. So this is one way to populate your array. Okay. Cumbersome. 1, 2, non-interactive. 3, that means it's hard-coded. So it only works in limited number of cases. A better way to do this would be to interact with the user. So let me comment this out. And we're going to interact with the user. And because we could do it in more than one way, I could do it, but the most efficient way would be with a for loop. I know exactly how many elements I need to capture, let's say 5 quiz scores or 5 lucky numbers or whatever. I'm going to use a for loop, most elegant way. All right, so I'm going to prompt the user to enter a number. Okay, and I'm just going to leave it like this. Enter number. We're going to leave the cursor right there. So that's why I'm not going to put end line. And then we're going to read this into my array. Now I want you to draw parallel what we were doing here. In the loop, this is 0. Index is 0. So my array sub-0 is going to get the value whatever the user enters. So here I hard coded it 0, 1, 2, 3, 4. Here I'm gonna, whatever user enters, I'm gonna capture and put it in 0. Then we check is 0 less than 5? Yes. We're gonna increment it, right? Then this becomes 1. Then we take care of the second position in the array, we populate that, and third position, and so on and so forth. Okay, so let's see what this does. I'm gonna share this with you real quick. You can paste it in your IDE. And then let's try it. So right here. So enter number 1, 2, 3, 4, 5. And look, it captured all that. And then it's displaying it with this loop. Okay, so you learned loops. Now you're learning arrays, and now you're synthesizing those two things into how to use arrays, how to populate your array, how to display contents of your array, and soon you're going to learn how to pass your array to function, and that function may perform certain operations on that array and return maybe another array, or maybe return some value. Maybe you want to compute average, maybe you want to find minimum, maximum, or if it's an array of strings, maybe you want to find a particular city, whether it exists or not, and so on and so forth. Okay. Any questions, guys, on this? Are we good? Yeah. All right. So let's take one more quick look at this. We can perform math operations on your arrays. So for example, let's say I populate my array, and I'm not going to display it yet, but I want to perform some math operations. So I may want to say that something like this. Let's say I have, let me do it slightly. Let me do it in a different program so that I can, so this doesn't become too complex and too commented out. So you, when you review the code, that you don't know what you're looking at. Okay. So anyway, this is what we did. Then here we learned how to access array elements through subscript, and that's why we say sub 0, sub 1, sub 2. You can also refer to it as index. And the last one, remember, whatever the dimension of your array is, the last one, the last subscript or the last index is dimension -1. Okay. So here is assignment. We're assigning this integer literal to tests in position 0, index 0, sub 0. Here we are displaying that. Here we're reading, which you saw a moment ago, into position 1. And then this is what I want to show you. You can perform math operations on your arrays, right? You can, it doesn't have to be, you don't have to store the result in an array variable. You can store it in something else, like an integer variable or whatever, right? Now, this one here will give you the address of your array. Let me elaborate, then I'll show you these two things, the math operations and this. When you allocate your array, and you do tests, and you have, in this case, let's say 5 integers in there, so 5 positions. So here's position 0, position 1, position 2, 3, and 4. All right. And the name is basically a pointer. Okay, so this is your test. So arrays, you don't know about pointers. You're going to learn about pointers towards the end of the course. And the name of the array is basically just a pointer. Let me show you that real quick. So keep this image in mind. We're going to switch quickly to C line so I can show you this. And let me do a new project. This is going to be source code 02 or 01 rather. And this is this, let's say, displaying array elements. Okay, let's do it in this window. And let me just clean this up a little bit. Let's do int. I should have copied that code. I apologize. So let's, okay. So let me declare constant. So constant integer ARR size or max array size, and let's make it 5. And then here, I want to declare my array. And in this case, let's do integer, and then that's my array. And then let's just give it a couple of values here. I just want to display this. So I'm going to do just 1 or 2. So let me do my array or ARR. Let's use ARR. Sub-0 is 1, 2, and 3. And we're not going to worry about the rest. Okay. Now I'm going to do this std cout, and I want to display ARR. It's going to give you an address. It's going to give you the address of this block of memory. Okay. So see, when I run this, I'm going to get this. This is a hexadecimal address where your array is located. Okay. And, you know, in your textbook, they say this is not legal. When you work with pointers, you're going to learn that you can actually use addresses to advance through the array, so you can point it to different memory locations. So I wouldn't say it's not legal. I would say that it displays the address of the array. Okay, but you're not going to see anything else, just the address. Okay, if you want to see the contents, then you need to go through the index. So in this case, index of 0 is going to give me the first position. And it's going to tell me that this is 1, which is correct. And then index 1 is going to give me 2, and so on and so forth. All right, now, I didn't initialize this array fully. So here I have 1, 2, 3, and then we don't know what I have here. Let me show you that. I'm going to do a loop here to demonstrate that. So 4, and I'm going to go from I is 0, I is less than ARR size, and I want to display contents of my array. And you're going to see some garbage here. Okay, so let's take a look at that. So I go from 0, array size 5, I increment that, and I'll keep displaying 0. Sorry, let's display I. I apologize. Let's try that. So 0, 1, 2, 3, 4. So position 0 has 1. That's correct. Position 2 has 2. Position 3 has 3. Pardon me. Position 0 has 1. Position 1 has 2, and so on and so forth. But then the last 2, they have this, which I did not enter. And the reason for that is when we declare an array like this, because it's local variable, it doesn't get initialized at all. Okay, so this is what I'm doing. I'm giving it values. Now let me move this. Let me show you. We concluded that global variables are not okay, and this now makes it a global. So this is a global variable. You're going to see one difference. I'm going to run the same program with that one change. But you're going to see that the last 2 elements, they have zeros. So when you declare an array as global, which you shouldn't ever, unless you want a 0 on that assignment, then don't do it. But, you know, in the past, I've given zeros to whoever uses global variables because of, you know, how dangerous and how bad global variables are. But one good thing about global variables is that when you declare it like so, it initializes the entire array in case of numeric data type to zeros, in case of string data type or character data type to blank string and blank character, right? So that's a good thing, but it outweighs the bad things outweigh this good thing. All right. So what are we to do? We're to keep initializing it locally. So here it's a local variable, but then I have this problem because it now gives me garbage in there. Okay. I can mitigate that I can mitigate that because we have something that we call list initialization of an array. So I'm gonna comment this out for a second or delete. All right. And then I could do something. Actually, let me leave it. Let me leave it. I'm gonna show you what you could do. You could do this. You could, at the time that you initialize your array, you could do something like this. Okay, so that means that you're setting your array, that you're initializing it to all of its members, you're initializing it to zeros. Okay, so let's see, and then you're overriding that here with, let's change it, let's make it 10, 20, and so on and so forth. So let's say 10, 20, and let's say 30. Okay, so now I'm not gonna have that garbage in the back, you see? And if I don't initialize this, that's what I was gonna do. And if I run it, you're gonna see that it has all zeros. So pretty easy for you to do that. Okay, so that's one way. I believe you can, this is if you use, I think it's C++20 compiler, don't quote me on that. You can do this as well. It's going to initialize them to zeros. So this does it. And you could do this. Oops, pardon me. You could do this. You could initialize it like that to 0. So several ways for you to accomplish the same thing. So you see, there's no need. It's very simple. There's no need to use global variable. You just need to do one of these. So I'm going to leave it like this. Now that you've seen a couple of them, and then I'm going to open these to show you that you can override, because initially it's all zeros, and then you go to position 0, you put 10, 20, and so on and so forth. So see, now you're going to end up with 10, 20, 30, and then 0, 0, 0. Okay, now after we do that, I want to compute, for example, let's say for position 3, so ARR position 3, I want to say that that's going to be a sum of ARR position 0 and ARR position, let's say 2. So in essence, what I'm saying is that I want 10 plus 30. So in position 3, I want to get 40. Okay, and then for the last one, I can just say that ARR sub 4, and I want to maybe multiply that. I want to say that ARR, let's say position 2 minus, let's say, ARR sub 0. So what's ARR 2? It's 30 minus what's in position 0, 10. And you can do it that way. Okay. Now let's see what we end up with. And you see how you have 10, 20, 30. That's the initial ones that we hard-coded in. And then 40 and 20 were computed by applying math operations on individual array members. Okay, do I always have to use array members? No. I can use one array member. For example, I could use something like this. I could say that array ARR in position 3 is, let's say, ARR position 0, which is 10. And I can multiply that or add 10, 24 to it. Why not? Okay. And then I could say the ARR in position 4 is maybe 1024 minus or divided by ARR. Let's say it's going to give me an integer, so I'm going to leave, let's say position 1. Let's see what this does. Okay. So we run this and it's going to give me 10, 20, 30. Then here we took 10 and we added it 1024. So that's how we get 1034. Then we took 1024, we divided it by 20. So 5 and then 24 divided by 20. That's going to give me 1. And then because it's integer arithmetic, you just get 1, you don't get You don't get the rest of it. Okay. So any questions, guys, on this? Is it making sense what we're discussing here? Is it working? Are you wrapping your head? Yeah, great. Okay. So let's go back to Tony. Got it. Let's see what else he has to say. So we're printing contents of an array. We know how to do that. We know how to initialize array. And then next thing we're going to look into is we use loop here. Okay, and then see here we're summing elements of the array and so on and so forth. We can compute average and, so try that at home, and then you can also try this. This would be an example of a range-based loop. Okay, so what's a range-based loop? Let me show you that real quick. But before I show you that, I want to show you something else. I mean, let's diverge a little bit from Tony's presentation here. I want to show you a couple of things that we ought to know. Did I skip any of this? Did I skip? No. Did I? No, I think I skipped. Yeah, I skipped a few things. Yeah, I realized that. Okay. So we did something here. So we did this, and then we kind of sort of did something like this where we, in a loop, we displayed contents of the array. Here he's displaying them one by one. And here he's using an identifier, a variable, as an index. And then he sets the value for it. So this can be used in a loop, right? And here's an example how to step through an array. So you have a constant, and you declare your array, and then you are setting each one of them to 99. Okay, so you can do that. All right. Now let's do the following. We did this. We talked about global array. All elements initialized to 0, local. All elements are uninitialized by default. And then we need to talk about this. This is what I wanted to talk. This is what I wanted to discuss a moment ago, but apparently I hit the wrong slide. All right, let's create a new project. There's a quick way for you to initialize an array. And there's two ways to do it. Okay, let me show you both. So this is going to be source code 02. And we're going to call this explicit list initialization. Okay, so explicit. Pretty simple. Oh, I should have copied that code. Okay, let's try again. So int main. All right, so I have constant integer, and let's call this max array size. Notice that I'm writing my constants in capital letters. Helps me when I look at the code realize, okay, that's a constant rather than a variable. So let's make this 5. And then I want to initialize this with a list. Okay, so I'm going to change, rather than always initializing an integer array, I'm going to go and do a string. So std string, so you can see an example, and string, and let's call this cities. Okay, and rather than initializing it like we did before with a loop and asking the user and all that, this is another way to hard code your array contents. So you open and you have an open and close curly brace. Then here you type Miami, whatever city you want to put in. So I'm going to type Miami. And we're going to type, let's say, Naples. Let's go to Tampa. And then let's leave it right there. Okay, so I have 3 rather than 5. And I want to display this. So you're going to see a couple of things here. So 4 int I, and then let's display cities. All right, let me share this with you so you can try on your end, your IDE. I didn't put all of them. I have 5, so I have 2 slots that I didn't put cities in. So let's run, let's see what it does. So it's gonna show Miami, Naples, Tampa, and then nothing else. See, it doesn't show anything else. Okay, and for you to see that this is, we can put a breakpoint here and see it, or we can just say city like so. And let's put right there. Okay, so now you're gonna see that it prints the other cities, the other ones, but it unlike when we initialized, pardon me, unlike when we declared an array before without list initialization, we don't have garbage here. Why? Because list initialization, the way it works, here we have our list is smaller than the array size. And, you know, elements in this list, Miami, Naples, Tampa, they have ordinal number in that list, meaning they have position in that list. So Miami is in position 0, thereby it goes to array position 0. Naples is in position 1, and it goes to cities position sub 1, and so on and so forth. The last 2, the list was shorter than the size of my array, so we got blank strings in here. Okay, so that is a quick way for you to test your program. So you initialize it with a list, and this is explicit because you're telling your compiler that it needs to allocate 5 elements here. It needs to allocate 5 because that's what the size is. So this is known as explicit. So this is explicit list initialization of an array. Are we okay, guys? Make sense? Yeah. So
Yep.
key takeaways: list can be shorter, then the number of elements in your array can be longer. So it can be shorter or the same length, but it cannot be longer. So here, if I have a couple more, so let's go east, let's hit Orlando, and then let's go down to, let's say, Melbourne. Okay. Confused. Let me just make it like this. It doesn't have to be in. So I have 1, 2, 3, 4, 5. Why is it giving me this? Let's see. Let me print it out. It's complaining about something. I honestly don't see it. Let's see. Let's see what it does. Why is it complaining? Melbourne. Doesn't like Melbourne for some reason. So I got Miami, Naples, Tampa, Orlando doesn't have. Where are my C++ programmers? Sherry, I'm calling you. You let me down. You missed that double quote. Okay. All right. I didn't have the quote here, so that's why it was complaining about Melbourne, but it was that. So I was waiting for you to correct me, but thank you. All right. I know you were about to, right? You just didn't want me to feel bad. All right, let's compile this and see. So this list is going to work. It's going to show us all these cities, right? Now let me add a couple more. So we proceed south and what did I do? So I want to proceed coming down towards Miami, and let's say we have West Palm Beach, and let's say I have another one, let's say Fort Lauderdale. Okay. So I won't be able to initialize it because it has a problem. See,
Yeah, because the max array size is 5, it wouldn't work.
Yeah, so it doesn't work. But if I make this 7, then obviously it's going to work. And see the beauty of having only global constant and then using it here and using it here, I made only one change. I made this to 7. Otherwise, I would have to change it here and change it here. And see, now I displayed it. So takeaway from this discussion, list has to be equal size of the array or smaller. Otherwise, it's not going to work. If it's smaller, then the last two elements or the elements that have not been initialized, they will be set to blank string. In this case, if it's numeric value, they will be set to 0. Explicit, okay? Now we also have implicit. Let me show you implicit real quick. So I'm gonna do something. Actually, let me copy this and I'll do it in a new project. So when you review this, you are not confused with the comments. So source code, this is going to be 03. This is implicit list. And initialization, sorry, initialization. Hopefully I spelled it correctly. Okay, let's do it in this window. Let me paste it, and we're going to make a couple of changes to our code. So implicit means compiler is going to imply. Compiler is going to figure it out. So I'm going to get rid of this, and I'm going to make this implicit. And I'm going to get rid of this here. I'm going to have a slight problem with this because max array size, but we're going to figure that out. All right, so here I declared, and since I know that I have 5, I'm going to run with integer literal here.
You missed the I in implicit.
Oh, Thank you. See, I got C++ programmers' attention to detail is what makes great C++ programmers. Thank you. All right, so why is it still complaining? No, look at that, it works. Let's try it. So it's going to show all of them, but I never declared the size of the array. So the way this works is the compiler looks at your list and it knows how many elements are in the list, and then it allocates your array accordingly. And to prove that, I can add a couple of more places. So I'm going to add West Palm Beach. And I'm going to add, let's say, Fort Lauderdale. Right, and then I'm going to change this, and I'll show you what to do in this case. The worst thing you can do is go and count. Go 1, 2, 3, 4, 5. That's the worst thing you can do. Okay, so you shouldn't do it. You should programmatically figure this out. All right, and that's coming next. But now let's take a look at it and see. The compiler figured it out, and we get all of our cities. No complaints, nothing. I never told it how big it is, how big my list is. So it does that by looking at your list, knows how many elements that list has, and then allocates your array accordingly. Now, what do we do about this? We don't want to count. So you could do a couple of things. One is you could go here and compute the size, okay? And that's easily done. So I'm going to declare a variable here, data type integer, and we're going to say that this is array size. And then the way I'm going to compute that, I'm going to say that array size is, I'm going to take size of, you know about size of function. We've covered it in the past. And you could do this with cities sub-0. That will work. That's what the AI tool here is suggesting. Or you could do, because you know the data type, so you could do std string, pass that to the size of function, and it's going to return that. So we're taking size of array. Remember earlier tonight when we started, I asked you something like this. I asked you, let's say we have a short. We know that short is 2. And let's say this is my array, and I have 10 of them. And I asked you, how big is this? And you all told me that this is 20. So that is the size of that array. So here we have strings. String is an object, so I'm letting the compiler figure that out. So I'm passing cities to it. It's going to get size of it. And then I want to divide that by the size of one element, which is string. Okay, so that's what we're doing here. And this is going to, oops, let me clear this. This is going to tell me what that is. And then I'm going to use it here as in my test in the loop, right? And look, we're going to purposely delete, let's say, one of these, just to make sure that the compiler is going to compute this correctly, and it does work. And it shows you Naples, Tampa, Orlando, Melbourne, West Palm Beach. So implicit, you don't need to specify, the compiler figures this out and you are good, right? However, this is okay if you are testing your code and you need quick data set, like so, you list initialize it, you do it. The downside of it is that it's still hard coding. So that makes your programs inflexible. So you wouldn't do this for production level code. Now, some things you may, because some things don't change, like days of weeks, Monday, Tuesday, Wednesday, Thursday, Friday, so on and so forth, or names of months. So you could list initialize that and use it in your, even in your production code, provided that it's only going to be used in English speaking world. Otherwise, you would have to have it, internationalized and so on and so forth. Okay, but for our practical purposes, this is a way to do this. Now, any questions before I move on to, is this making sense to you guys? Is it clear?
Yes, yeah.
All right, now, this, you can circumvent this by using a very elegant solution, which is called range-based loop. Okay, so this is going to be an example of a range-based loop. The way you do this, range-based for loop. Okay, you know that for loop is a very elegant solution. Here, I'm going to say something like this. I'm not going to use index-based loop. I'm going to let the compiler do all the heavy lifting. So I'm going to say for city in cities. Okay, and I need to specify the data type. So std string. And all I'm going to let it do is I'm going to have it std cout, not that cout, but this one, it's going to display city. So with range-based loop, I don't need to worry about how many elements I have. The compiler is going to worry about that. And I'm going to show in a minute that you don't need to worry even about the data type as well. Okay, so look at that. It's going to display them all just fine. All right, so that's a range-based loop. Very, very elegant, very pretty solution. You don't have to compute size. You don't have to use index like we're using here. And you won't have to use even the data type, but be warned that you have to, you can just do something like this, auto, and it's going to know which data type this is. And it's going to display all these cities, Miami, Naples, Tampa, Orlando, and so on and so forth. Now, if we add another one, we don't have to worry about anything. So here, if I go and add Fort Lauderdale, that is not going to be a problem. It's going to print all that. Okay, so range-based loop. All right, let me share this with you. Hopefully it's going to fit. All right, so please take a look if you want to try and compile it on your end. So this is what we covered here. So here's a list initialization with numeric data. When you're looking at this, is this implicit or explicit? Just by looking at it, at this line here. Implicit or explicit, real quick.
Explicit.
Explicit. How do you know? Because you're telling it the size. When you don't tell it the size, your compiler is going to imply. That's why it's implicit. Okay. So here's a couple more examples. What you can do here, he's got months, and the syntax is you have your array, and you have the size, then you have assignment operator, curly brace, ending curly brace, semicolon. And then elements are separated by commas. In this case, these are integers. And he's printing month 1 has 31 days and so on and so forth. Okay. So this is how it works. We saw uninitialized elements. They're set to 0 if these are numeric. They're set to empty strings or null characters if they are cars. All right. And then implicit is that compiler determines, and you use this thing, empty. Okay, so size declarator is empty. Okay, now, no bounds checking. This is very important topic because the compiler will never complain if you try to go beyond the bounds of your array. So this is totally up to you. And you're going to, here I've got short code, I'm going to paste it in there for us to try. So let's take a look at that. So this is the premise. You have your array, like so, and you've declared you have a few elements. So here's 1, here's 2, 3, 4. I should have made it a little bigger, otherwise I'm going to be here all night drawing this, but let's just do it. So they look reasonably same size, right? So this is your array. You declare this array, and then these are your bounds. These are your bounds. Okay, so this is memory here beyond your array. This is memory before your array. So you don't want to go here, nor you want to go here. Most of the time you may venture here. Okay, so what lies beyond the bounds of your array, we don't know, because compiler picks memory and allocates it for you, for your array. But then here you may have some values that belong to some other program. And if you're trying to add something here, and this is memory location that's used by another program, your code, your program may crash, or you can cause your computer may lock up and things like that. So you don't want to go beyond this. So when that happens, and if it does happen, reboot, right? So let's see if we can demonstrate that. Now, I don't think that my Zoom program is going to have any variables after the bounds of the array that I'm about to show you. But if that happens and we get disconnected, consider that in tremendous luck. I'm going to be on my way to buy a lotto ticket because I don't expect it to happen. Okay, so let's see. All right, let's try this. All right, let me go back to Sea Lion, and I'm going to show you a brief project that I have here that demonstrates that. So we're going to make this source code 04, no bounds checking. And let's do it in this window. And this is my code that I prepared before. So this is what we have. Let me paste it so you guys can take a look at it. And I'm going to take this guy off here. We're not going to debug now. So I have an array and its size is 3. Okay. And I am interactively populating this array. Okay, so here I'm going to go to array size first to show you. So it says, give me a number. So give me day 1. And this is sorry, I'm not collecting numbers, I'm collecting days. So let's say this is Monday. Then day 2 is Tuesday. And day 3, Wednesday. And it printed them very nicely here. Okay, nothing wrong with that. Now I'm going to change this instead of going to array size, because here everything is controlled, it's tightly controlled. So here I'm going to make this go to 7. Let's try again. Let's see if we can crash this. So day 1, Monday. Day 2, Tuesday. Day 3, Wednesday. Day 4, Thursday. And see, it crashed with this code. 138 interrupted. So it wasn't that bad of a crash, but it did crash. We never got to finish, which means I'm accessed beyond, because my array is only 3 elements, and I accessed beyond that. So you are the only one, you, the programmer, are the only one who can control that. As you see, there was no warning, there was no, you can't do that. And when you do it, it just happens. So be aware of that. That is one of those things that you really need to be on the lookout. So when you use your index or your subscript that is not, within your array, C++ will never check for that. Okay, and it's going to be happy to let you go beyond the bounds of your array, right? And here's an example similar to what we just did. And this is what you have. This is what we declared. You have 3 elements, and then obviously you have memory before that, memory after. And then we're trying to access things here. Now this, we don't know which program uses. Maybe nobody is using it. Maybe it's garbage. We don't know. We don't know, but nevertheless, if you're trying to store something in there, it may work. It may work, may not crash, but it's not good. You shouldn't be doing that. Okay. So these are some pointers. Don't use invalid subscript. You can corrupt memory locations. Okay, so maybe my Zoom program is using those locations, and maybe my Zoom stops working. We don't know, right? Your program can crash. You saw it. Can lock up your computer, or you can get these bugs that you have no idea what they are. And when you have a large program, then that is not easy to detect. Now, advice: use these guys. When you do it like so, here I was doing it on purpose, but when you do it like so, then it's controlled. It's controlled. You use named constants throughout, and it's very controlled. You are in control of your code. That's how you want it. You don't want this to be, you want to control your code, not the other way around. Okay. Questions, guys? Doing good? Got a couple more
Yeah,
demos.
good.
Yeah, so we're clear on this. All right, let's take a look at what this is off by 1. This is very common for novice programmers. Okay, let me demonstrate that. Let me go here. This is going to be source code 5 off by 1. It stems from that, that we're used to, we humans are used to, that we, when you say first position, we associate that with 1. But in computer science, we associate that with 0, and your array index starts at 0, as I explained earlier, because of how far you're offsetting in that block of memory. So this is source code 05. This is going to be off by 1. So let's see off by 1 what that's all about. Let me copy this. So I have an array, and I list initialized it. And I'm going to share this with you as well. And I want to display contents of my array. So I'm going to go and display it. And see, I'm getting garbage here. Why? Because I put equal. So the way this goes, it goes 0. We initialize your index to 0. Is 0 less or equal to 5? Yes. We execute this line of code. We come and increment. Index becomes 1. Is 1 less or equal to 5? Yes. we execute, we increment is 2 less or equal, yes, is 3 less or equal, is 4 less or equal, is 5 less or equal, yes, it is, and we try to access what's in location 5, index 5, so 0, 1, 2, 3, 4, 5. We're in the Wild West. We have crossed the boundaries of our array, and here we're displaying some garbage that's there, okay? So that's one. Another one that a lot of programmers do, they say, you know what, I'm gonna go from 1. I'm gonna go from position 1, and I'm gonna go all the way to array size. And in this, actually, let me show you the correct way to do this would be less than. So you start from 0 and you do less than that. And when I display it, I'm going to get all my numbers correctly. So I get 10, 20, 30, 40, 50, and it's beautiful, right? Now, some programmers, they say, you know what, I don't like to start at 0, I'm going to start at 1. All right, and then they compile, they're going to miss the first one. So see here, they start with 20, they miss the first one. And moreover, they say, you know what, I'm going to go make it less or equal to 5. So I'm going to go from 1 to 5. And that's going to pose a problem. So see, you go 20, 30, 40, 50, and then you get garbage because you veered off into outside, you know, the bounds of your array. What I call Wild West. You veer there and you're stuck in there, right? So again, not a good practice, so be aware of that. So always start from 0. Always start from 0. All right, because your array starts from 0. And then we've covered range-based for loop. I want to show you one thing that we didn't cover, because let me show you one more thing. I'm going to show you. Yeah, we have time for me to show you this. This is an interesting thing here that I'm going to show you. Now, when you go for a job interview, you may be asked a question like this. All right, they're going to test whether you know prefix, postfix, whether you understand arrays and all that, all in one seemingly very simple question. So source code 06, I'm going to put prefix, postfix, prefix and postfix. Okay. And here's this short program. Let's look at it. And you guys know this from before. We've looked at it in one of the previous lessons. And now you need to apply all that here. Okay, so let's start with this. And I'm going to comment the rest of it. I have 10, 20, 30, 40, 50, and then I have inline statement. And I am doing, is this prefix or postfix? Right here. What is this? What do you guys see? I'm incrementing, and what am I, in which manner am I doing it? Pre or postfix?
Pre.
Prefix, excellent. So you know from the previous lessons that code executes from top to bottom, left to right. So left to right goes here. It's creating this string to give it to the cout object, and then it encounters the operation. This operation is, does anybody remember what plus plus does? We call it increment, but what does it do? Say it again, you were.
Add 1.
Adds 1, adds 1, very good. Now adds 1 to what? It's gonna look here at my array, position 0. What's in my array, position 0?
10.
10. So it's gonna add 1 to 10 because it's right here. And it's gonna display 10. Pardon me, it's gonna display 11. So it displays 11. So you guys know that from previous lectures, yes?
Yes.
Yeah, very good. Now, we're going to do something else. I'm going to copy this statement. Actually, I have it. I'm going to make it postfix. So this is going to be postfix. And instead of doing it here, I'm going to do it here. What do you think it's going to display here? Yeah.
10.
10. Again, left top to bottom, left to right. It goes here, says, oh, I need to display contents of this memory location called my array position 0, like that variable. Then I'm going to add 1 to it. So to show you what that looks like, we're going to display this statement. I'm going to uncomment it so you can see it. And by the way, this is postfix, not prefix. Okay. So here, line 8 is going to display 10, but then after that, you're going to see that it indeed incremented it to 11. Okay. So increment postfix is 10, and then after this inline statement executes, the contents of my array sub 0 is 11, and that's because after it displayed this, it proceeded to do increment in postfix manner. Okay, so far so good. We're clear on that? Yeah.
Yes.
All right, let's move on then and take a look at something else. So you know this, now I'm going to throw a curveball at you. So I have, let me see, I have something like this. So I'm going to display that. So that's going to show you the contents of your array. And then I'm going to use slightly different prefix and postfix. So let's do pre first. And instead of incrementing it here, I'm going to increment it inside. What do you guys think is going to take place here? Oh, so not 0. No, I can't do that. I apologize. I can't do it. I need to do integer index. And let's make index 0. And then I can do this. I need to do a variable. Okay, so we're still looking at index. All right, so what do you guys think is going to happen here? It's going to go here. It's going to say, I have my array. Okay, and then what do I need to do? What am I doing here? I'm incrementing what?
Index.
Index, right? The subscript. I'm incrementing the subscript. So subscript is 0. What is subscript going to be?
1.
1. What's in position 1?
20.
20. Remember, this is 0. This is 1. This. Okay, let's run. Let's see. So see, you can have something like that. So see, increment prefix displays 20. Okay, and then my array index at this point is, if we print what index is, so std cout, and we can say index is, or index like this, index at this point is going to be, we've incremented the index, and look, let me run it again. Index is now 1. It was 0, right? Does everybody see that?
Yes.
You're
Yes.
incrementing index, so you're not affecting the value, you're just moving to the next position in your array. So that would be prefix. Now, we can do the same thing with postfix. I'm going to copy this, and I'm going to also comment it out so that we can see. So this is going to be postfix, and I'm going to do it here, like so. And it tells me what the index is. It's going to move the index. I reset index to 0. And we're going to display what that is. All right, let's run it. So increment postfix. So it comes here left to right. It encounters my array, encounters index. What is index at this?
0.
0. So it displays 10 because that's what's in position 0. Increments the index. Index becomes 1. And then here, this is erroneous here that it says my array sub 0. This is my array sub index, I should say. My array, let's make it really, oops, guys, did I lose you? No, Because my screen went blank. We're still connected, yeah?
Yeah.
Yes.
Yeah,
Yes.
yeah. Okay, thank you.
Yes, we're still on.
Yeah, thank you. Sorry about that. Index. All right, so this is gonna be
You
more.
made a mistake.
I did?
Yeah, you put it in between. Oh,
No,
never mind. My
I
bad.
wanna do it on purpose, so it doesn't show array sub-zero, that it shows array and then the correct index. You see, it shows the index.
Oh, never mind. Sorry, my bad.
That's okay, yeah. All right, so that's that. So you know postfix, prefix, and then I'm gonna leave you with something crazy. Here we can have, let me just do. And I'm pretty sure you know how to solve this. I'm not gonna say what this is. But look, I can do this and that. And let's see what what that returns. It returns 21. So you see, I've incremented here prefix, and then I displayed that, and then here I have postfix, and I can have this. So anyway, what I'm showing you here, I want you to play with this. Do all these things, put a breakpoint, you know how to do it. Excuse me, run it like this to see what happens. But you know, it boils down is how does the code execute? Which one is going to execute first? And I'm pretty sure you all will know what to do with this. Yeah. Okay. Questions, guys, about this? Are we good?
Yes,
Yeah.
good.
Yeah. All right. So we know prefix, postfix. We're good. Now I want to show you an example of range-based loop. Let me open it with, I think, oh yeah, it's going to try to open Xcode. Just give me 1 second. I'm going to shut it down. Sorry about that. I don't want to download and install right now, so I'm going to opt out of it. See if I can quit it. Good. All right. So source code 07, I think we have enough time to demonstrate that. So source code 07. Yeah, I'll let you go after this. So source code 07, range-based loop. Okay. And in this example, I'm going to show you how you can populate, because previous I showed you how you can do this. So I have this short code. Let me share that with you and let me demonstrate it. So you've seen how you can use range-based loop to display things. And then here I'm going to show you how you can use range-based loop to populate an array. Okay. So what we have here is we have an array called cities, and its max size is 5. The most I can store in here is 5 cities. You know what this means? This means I zeroed it out, right? And then I want to populate it. So you've learned the references. And because you learned references, if I do something like this without a reference, if I do string, pardon me, std string, cities, I'm trying to populate it here and I'm prompting the user, okay, give me city name and I'm going to put it in, right? So this is a regular variable, not a reference, just a regular variable. This is not going to work. Okay, so see, I'm going to get nothing. Enter city name, let's say Miami, Naples, Sarasota, let's say Tampa, let's say Orlando. See, nothing in the output. I didn't store anything. So even though I'm using this very elegant loop, it's not working for me. The reason why it's not working is because this is just a regular variable. But if you use a reference, you learned about references, now it's going to work. And it's going to be, let's say, Miami, Orlando, Jacksonville, Naples, Tampa. You see, it prints all of them. Now it works. Now it works. Now, I could get away with, instead of doing this, I could get away with, just 1 second, with auto. That's a nice feature. And instead of saying string, but it has to match. I'll show you just 1 second to make my point, and I'll give you the floor. There you go. Auto is also going to work. So here, if we do New York, and let's say Miami, Chicago, LA, and let's say Orlando. And it does print all of them. Sherry, you raised your hand. What is your question?
I noticed that with Visual Studio, it doesn't recognize auto. Like it says that it needs to be initialized first. So I'm assuming that maybe it needs a library for auto, like string did.
In Visual Studio,
Yeah.
you want to share your screen with me? Just give me 1 second here. Let
Yeah.
me stop my share and all right, let's see if you can go ahead, share your screen. Let's see what you got.
Okay. This one. Okay. So I tried putting reference there at least to try and fix it, but
Do
at
me
the
a
very
favor.
least it says cannot deduce auto type initializer required.
Okay, do me a favor, put here it's not gonna know, but when you put reference, it still doesn't work.
No.
The reference still, like if you try to compile and it still doesn't work.
Yeah.
Okay, try string. Instead of auto, do std string. Let's see now, compile, let's see if this is gonna run, leave it like that, leave it as a.
Well, cities isn't
Oh,
working.
no, hold on,
It's covering.
hold on, you're missing something. You need a colon after the city, before cities, you need a colon. After the city, yeah, right there, colon. Yeah, not semicolon, but colon.
Oh.
Yeah, like that. Try now.
Zoom is covering. Let
No.
me
Oh,
see if I can drag this there.
yeah, you can stop sharing it. It should work. I think that's that.
Oh, go there still?
Yeah. What is?
Okay.
Is it giving you error
Oh,
on this still? Here, stop your share.
yeah.
Stop your share.
Yeah.
Try. I think that's gonna fix it. So let me.
Okay.
Yeah, stop your share and let me share mine. Compile. Does it work when you compile? You gotta have this colon here. Without that colon, it's not gonna work. See that? Let me put it there. Let me put it in the chat so you can try. It's in the chat.
Hmm.
Yeah, copy just that segment and put it in there. Let's see if that works. Is it working?
It's saying that there's a build error even though it says no issues found.
But is it on that same issue, or you know what you could do? You could start a new project and just I'll give you this code. Try just this code. Here, let me paste it in the chat. Start new project because it may be something from before.
Okay.
Yeah, go ahead and copy from chat and let's see if that fixes your error because that should work. All right, well, she's doing that. Any questions, guys, on what we covered tonight? This is a good stopping place to stop. Any questions, guys, on what we covered? So you've seen range-based loop, how it works. It's a very elegant way to use when with implicit string implicit array initialization. Also, when you have an array that has, whatever number of elements, you don't need to use an index loop. and so on and so forth, okay? But if you're gonna populate your array, then you need to use references. So I think this is a good place to stop, and here's an example. See, even here, Sherry, you gotta do it something like this. So you can use auto, and it will figure it out. But you need that colon, you need the colon. All right, so let's stop here. Any questions before we part ways?
Professor, can you give my attendance?
Yes, I'll take care of you. Sherry, did it work for you with new project?
It's saying that there's a missing brace, which does not make sense.
You copied my program.
And that auto doesn't deduce references.
All right.
Are you missing one at the end of return? Zero?
No, it says it's in line 6,
No,
which is with the int main.
no, he may be right because I didn't copy.
Mm.
Put a curly brace after return. After return 0, put a closing curly brace. I think that's it, and that's why it's called.
Oh, yeah. Yeah. Okay.
It works.
Yeah, it's all good.
All right, James, you're a C++ programmer, sir.
Thank you.
All right, all of you are. All right, guys, if there's no more questions, thank you. Have a great rest of the evening. If you came in late, stay. I'm going to take care of your attendance. Let me stop the recording.